On the evening of September 1st, 1859, the sky began to change. At first, it was subtle, a strange glow on the horizon, a shimmer where darkness should have been. Then, the light intensified. Across North America and Europe, the night sky turned crimson. Scarlet waves rippled overhead. Brilliant curtains of light flickered and pulsed. Auroras, usually confined to the polar regions, appeared near the equator. In some places, the glow was so bright that people woke, believing it was dawn. Newspapers described the sky as blood red. Some thought cities were burning, others feared divine judgment. No one understood what was happening. At the time, the most advanced technology on Earth was the telegraph, a network of wires stretched across continents. Messages traveled faster than horses for the first time in history. It was the internet of its day. And then it began to fail. Telegraph operators reported violent sparks leaping from their equipment. Paper caught fire. Operators received electric shocks. In some stations, the power supply was disconnected. And yet the machines continued to send messages. The sky was glowing. The wires were alive. The modern world was malfunctioning. For the first time, humanity experienced a global technological disruption caused not by war, not by sabotage, but by the sun. Earlier that same day, an English astronomer named Richard Carrington had been observing sunspots. He noticed something extraordinary. A sudden, intense flash of white light burst from the surface of the sun. It lasted only minutes. Then it was gone. He had witnessed a solar flare, though the term did not yet exist. 17 hours later, Earth felt the consequences. Charged particles from the sun had traveled through space and collided with our planet's magnetic field. What followed was the most powerful geomagnetic storm ever recorded. The event would later bear his name, the Carrington Event. The sun is not a static ball of fire. It is dynamic, violent, magnetic. Occasionally, it releases enormous bursts of energy known as coronal mass ejections. Billions of tons of charged particles are hurled into space. If Earth lies in their path, our magnetic field absorbs the impact. Most of the time, the result is simply beautiful auroras. But in 1859, the storm was extreme. The magnetic disturbance was so strong that it induced electrical currents in long metal wires across the planet. Telegraph lines acted like antennas. The Earth itself became part of the circuit. The technology of the day, simple though it was overwhelmed. In 1859, the telegraph was the only global electrical infrastructure. There were no power grids, no satellites, no aviation systems, no digital networks. The storm disrupted communication, but society continued. Today, the situation would be different. Modern civilization depends on interconnected systems. Satellites guide aircraft. GPS synchronizes financial markets. Power grids stretch across continents. The internet underpins everything from hospitals to water treatment. A storm of similar magnitude would not be a curiosity. It would be a systems test. This was not a one-time anomaly. In 1921, another severe solar storm damaged telegraph and railway systems. In 1989, a geomagnetic storm caused a massive blackout in Quebec. 6 million people lost power within minutes. In 2012, a powerful coronal mass ejection crossed Earth's orbit, just days after our planet had moved past that exact position. Had it struck, scientists estimate the damage could have reached trillions of dollars. It is not that the sun has grown quieter, it is that our planet has grown more connected. There is a paradox at the heart of modern life. We are more technologically advanced than ever, more efficient, more connected. And yet, that connectivity creates vulnerability. The telegraph network of 1859 was simple. Today's infrastructure is layered, interdependent, and global. When one system fails, others cascade, Power supports communication. Communication supports logistics. Logistics supports food supply. A solar storm does not need to destroy buildings. It only needs to interrupt the flow. The question is not whether such storms will happen again. They will. The real question is how prepared we are to absorb them. The night the sky turned red was terrifying, but it was also beautiful. Auroras shimmered over places that had never seen them. Newspapers printed vivid descriptions. Artists sketched glowing horizons. People stood outside and stared upward. For a brief moment, the modern world paused and was reminded of something ancient. That we live beneath a star. That our planet is not isolated. That the forces shaping our lives extend far beyond human systems. The Carrington Event was not just a storm, it was a revelation. It exposed the fragility of early technology. It showed that infrastructure can be disrupted by forces beyond politics or intention. It demonstrated that progress does not eliminate risk, it transforms it. Every civilization believes its systems are stable until they are tested. In 1859, the test came from the sky. The question is not whether it will happen again. It is whether we will recognize the warning for what it is, not a sign of doom, but a reminder of humility. On that night, the sky burned red. Telegraph wires sparked, messages faltered, the modern world trembled, briefly. Then the lights faded, the wires cooled, life continued, but the lesson remains. As humans, we measure progress by what we build. Perhaps we should also measure it by how well it endures. Join us every Sunday for deeper stories, bigger questions, and long-form explorations that go beyond the short videos. Because knowledge doesn't stop at 60 seconds.
Thanks for watching. This is 60-second knowledge now extended. Because curiosity doesn't stop at 60 seconds. Subscribe on YouTube and follow us on TikTok.